There are three key domains or elements of the work that JUMP provides. We certainly provide education, and I think everybody understands the need for a very high quality educational experience. But we also are committed to performance improvement research and to innovation.
One of the things that I always tell people is that simulation is not new, a new tool in the educational toolbox of training medical professionals. In fact, when we first started training physicians in the 1850s, we used simulation techniques to train clinicians how to do things. But what we've found is over that time, we've become very siloed in the way that we train clinicians. So we'll train doctors at a university and they never interact with a nurse until the day that they first step into a hospital. And we do the same thing with our colleges of nursing and all of our other professional training programs. What will make JUMP unique is that we want to train those students together from the beginning. We want to be sharing our curriculum across all those different institutions. We want to have the ability to utilize this asset to change the way that we train medical professionals.
We're just getting started here at JUMP Simulation. We have bold and audacious goals. We do plan to distribute our content through a national network. Through the use of the fiber optic network that comes right into the core of the building, we're able to distribute content out from JUMP. And we want to be right in front, a leader in providing the best quality education.
I get really excited about all of the possibilities that JUMP has with everything. So we have resources to teach, we have resources to help patients in more ways than just helping medical students. In the Innovation Lab, we have a lot of different resources going on. So of course the 3D printer and our new software, which is Mimics, it's really cool. We can take images of CT and MRI scans and actually produce a real 3D model out of that. We're working on a few different projects right now, for example, the gout simulator, which you may have heard of before. So basically what we're doing with that is we took CT scans of a patient with gout, printed out that foot, and we're working on a model that will have a fluid compartment in the toe area. So basically students can practice inserting the needle in there and taking out the synovial fluid to test it before they actually do it on a patient, because again, it's an inflamed joint, so you need that practice beforehand. The 3D printer that we have has two parts. So I send it an image from my computer, a 3D image, and it prints layer by layer. The liquid comes out onto the powder to form an image on that powder as the layers are added. It's a long process, but it's actually really cool. I think that medicine is catching up to technology in many different ways. Doctors talking to engineers is a very good concept that I think JUMP has nailed.
JUMP Simulation has a very definite research agenda. We have 10 ongoing research projects. All these projects are designed to demonstrate simulation's impact on patient care outcomes. And they range from newborn babies to obstetrics and gynecology, all the way up to intensive care unit care that's provided. Each of these projects has a special emphasis on training and excellence. And by demanding excellence from our learners, we know we can impact patient care outcomes.
In this study, what we're evaluating is the effects of sim-based training versus traditional training for insertions of central line. And the goal of this is to find the optimal form of training to improve patient safety, risks of infection, and complications of a procedure based on traditional training versus the ability to have the residents simulate the insertion of these lines. So in essence, what we're doing is we're going to look at two separate groups of residents who rotate through the medical ICU and give each of these groups different forms of training. One will get a didactic version of the training. The other group will actually have hands-on mastery training with realistic mannequins to practice over and over the insertion of the central line. And then we're going to compare the effects of that training in real life. We're going to observe the residents as they would normally insert central lines in real patients in the ICU.
This large intravenous is placed into the neck, and when it's done correctly, it's relatively low risk. But when it's done incorrectly, infection and other complications can strike. We know that there is an evidence base that proves that simulation has a dramatic impact on patient care in this area. We can prevent infections and we can reduce complications.